let's discuss about what is integration or what we call as antiderivative. See, we are looking at the concept of integration. Let's understand the meaning of this particular word integrate. See, integrate meaning what? To sum up things, correct? This is the basic understanding about what is integration. Now, integrate to sum things up. And when you say differentiate, you're going to split things up, correct? Now, to give you a very simple understanding about what is integration and what is differentiation. Now, why I'm talking about differentiation also is because integration is the inverse function of differentiation. That's why. Okay. Now, differentiate meaning to split things or to segregate or to make things into different parts, correct? That is differentiation. That means differentiate, correct? So imagine you have a line like this. So when I say line, need not be a straight line. Any curved line will also work. Now, this particular curved line, say you're going to split this into multiple parts. So when I say multiple parts, let's say one like this, like this, like this. So split this into multiple parts. Fine. Now, once you split it into multiple parts, if you segregate each and every one of them, so what you'll get like this, like this, like this. So you're going to have different pieces, correct? You'll have different pieces. Now, this process of splitting things up, this is what we call as derivative or differentiation. This is differentiation. Now, when you integrate meaning what? To sum things up, to come together. That is integrate, right? So when you say integration of a function, that means you would have split the function into n number of pieces. Like in this case, you have a line. That line has been split into n number of pieces. Now you are going to sum things up. That means you are going to add those pieces piece by piece by piece by piece. When you add everything, don't you think you'll get back the function again? That means these small pieces what you have, when you add them, when you integrate them, so when you integrate, you're going to get this function back, correct? So this is the concept of integration. See, when you do integration, see, this is integration. This is differentiation where you split things up. And integration is what? You add things up, right? So the concept of antiderivative or integration. So the general part, whatever you are going to understand, is the indefinite integral. Now, indefinite integral is more of the algebraic way of approaching the integration. Okay, now that might sound a little counterintuitive because you're trying to understand what is integration, and we are explaining that with the help of the word integral, correct? Now let me make you understand what it is. Now, indefinite integral meaning you are going to sum up things like what we are looking here. So you have those pieces, correct? And those pieces, whatever you have, you're trying to sum each and every piece up. Now, you don't have a starting and an ending point. That means you're going to keep on adding indefinitely. Okay, indefinitely you're going to keep adding things up. That's why this is what we call as indefinite integral. Fair enough? So indefinite integral in the sense you have a function f of x. Say that your function is f of x. You're splitting this function f of x into n number of pieces, n number of slices, you can call it. So those slices, you sum it up again, you add them up. Once you add them up, you're going to keep on adding indefinitely. That type of integration is what we call as indefinite integral. Indefinite integral. Just because you have the word indefinite doesn't mean it's infinity or something like that. No, the algebraic method, we'll look into that part later. All right. Whenever we look into integration, especially indefinite integrals, because right now we are not going to discuss about definite part anyway. Now, when we talk about indefinite integral, what does that actually give you? Now that you have understood what is indefinite integral, now you'll understand what does it give you? Like, what is the meaning of that integration? Fair enough. Now, to understand the meaning of the word or meaning of integration or antiderivative, now most of the indefinite integrals, they are going to give you the family of functions. Okay, so let's understand what is a family of function. All right. To understand this family of function, imagine you have x and y axis, say this is 0. Yeah. Let's take a very simple function. Let's say you have x square. So f of x is equal to x square. Okay. Now, when you have x square, you know that the function is a parabola touching the origin, which is quite simple. That means what we'll do, let's say we are going to draw one parabola like this, and it's going to go up like this. Correct? This is the function f of x is equal to x square. Now, suppose say you are going to have f of x or f of x1, it's another function, is x square plus 3. Okay, x square plus 3. That means for this one, the graph is going to be somewhere over here. The graph will be something like this, right? F of x square plus 3. This point is 3. Now what I'll tell you is differentiate f of x here. So f dash of x becomes 2x, correct? Makes sense? And here also f dash of x becomes, or f dash of x1, right, is equal to 2x, because anyway derivative of 3 is 0. Now look at these two. Look at the two derivative functions, f dash of x and f dash of x1. Both are 2x. So how are you going to differentiate which graph is what? That means there are two functions, right? Just by the derivative, can you identify what is the graph and how does it look like? No, right? It's never possible, because when you have 2x, fine, 2x is therefore x square plus 3 as well as x square. Or suppose if I'm going to consider another function, let's say if I take f of x2 is say x square minus 3. How do you differentiate? You cannot, right? Because all of them will give you the same derivative. All of them, if you differentiate, the answer is the same. This is where the concept of indefinite integral comes into play, which is a very important point. Okay. Now, what what indefinite integral is going to do is it takes the derivative function and then reverses it back into its original function. That means it's gonna take the value of 2x, and from 2x you will get back this particular function. Understood? Obviously it will, because integration is the inverse of differentiation. So when differentiation is going to split the function, integration is going to add those functions. Understood? Now when I say add the functions, don't assume f of x, g of x and it's adding. Not like that. The splits whatever is happening within the function and within the interval, whatever it is, that integration is going to add those things up. Fine. Now look at this one. F of x is x square or x square plus 3, x square minus 3, no matter what it is, your derivative is 2x. So when you do integration of 2x, you'll get it as x square plus c. Now this plus c is an important point here. Okay, so the plus c represents the constant. Plus c represents the constant. Now what is the meaning of this word constant here? That too when we are integrating. Okay, we call it as integration constant. or constant. I mean, generally integration constant is what we write. But now even if you write constant, that's okay. That's not an issue. Now you got x square plus c, but I did not get x square. I did not get x square plus 3 or x square minus 3, correct? Neither of them. So how do we show or how do we understand that indefinite integrals do actually give me the value? That is nothing but the family of curves. In the sense, when you have x square plus c, c is a constant, right? So when I say integration constant, that constant can be any number. It can be 3, it can be 0, minus 3, blah, 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 whatever, whatever. Isn't it? So when you have x square plus c, this value c, what you are seeing, c can take any real number. Any real number. Understood? Depending on your example, it might change. So that tells us what is the meaning of indefinite integral. So what does indefinite integral gives you? When you integrate, you'll get back the function plus some constant c. So this is going to give us the family of curves. Okay, let me repeat again. The meaning of indefinite integral is that it is going to represent the family of curves. So in this case, x square is the function of parabola, or you can say x square represents the curve of a parabola, correct? If you write x square plus c can take any value. So that means here the graph is going to look completely different. Like you can have one more like this, or you can have one more something like this, right? But then the only thing is it should be x square plus c. I cannot have 3x square, 4x square, 5x square. No, that doesn't work. X square plus c. So because of that integration constant, my graph can go anywhere along the y-axis. So you are going to get a family of parabolas here, correct? So in general, we call it as family of curves. That means a very important point is, one, the takeaway from this particular video is, one, you understood that there are two types of integration, correct? Second, you understood that there is algebraic as well as a geometrical method, right? So in this case now, indefinite integral, what does it give you or what does it represent? It represents the family of curves. Okay, in this case parabola, in general it can be anything. Fine. So this is what we call as integration. Now in the next video, we'll do few properties, not problems. We're not going to jump into the problems right now. We'll solve few properties and few maybe theorems related to integration. All right. So all these things we'll do it in the next video.